I think at least once in your life you play in this game. Two-player game where participants they turn smart in spaces in a 3x3 grid with their respective symbols. Today we will talk about front-end system design for this game. We will talk about functional requirements, non-functional requirements, assumptions, interfaces plus API, optimization, algorithms, and accessibility. So let's start from functional requirements. The first one is multiplayer operability. Users can play against a computer or another user. The next one is game initiation. Users can choose who starts the game. The next one is time limits. Each move is time-bound to ensure fluid gameplay. The next one is customization. Users can customize the board size and select different icons. And the last one is termination and replay. Users can end the game at any point and have the option to replay. Non-functional requirements. Fast response times are critical, especially for larger boards or network play. So here we will talk about performance. And the next one is accessibility. The game must be usable by people with disabilities, ensuring broad usability. Now let's make some assumptions. Users login and profile are already done. Users can find each other before the game, so we are not going to work on the user's profile functionality and login. Now let's talk about interfaces. When we initialize the game, users must provide some data. The first interface is game setup. The first field is size. Positive integer defines both the width and height of our board. Time limit per move. Seconds allowed for a player to make a move. Must be positive. The next one, player IDs. Array of exactly 2 player IDs indicating the participants of the game. Where computer has also unique ID. Before we start playing we have only one ID there. The next interface is game, which extends game setup. The first field is game ID, is just ID the game session. The next field is moves, trace the sequence of moves with player ID and board position. And status, reflects the current state of the game using the game status enum. Now let's talk about our users. Our user has ID, name, photo URL, and rating. Numerical rating representing the user's skill level will be used for matchmaking purposes. The next one is type position. Defines the position on the game board using a zero-based coordinate system, row and column. And our enums. The first one is game status. It can be pending, in progress, win, draw, completed. The last one is icon, enum containing identifiers for each icon a player can choose from. Now let's talk about API. For starting a game, a classic REST call is our best bet. It's simple and there is no need for real-time updates at this stage. When players are browsing for games to join, REST would work, but it might not reflect the most current game availability. We might think about short polling, where the client checks in at regular intervals for updates. The problem is that it can lead to unnecessary network traffic and server load, especially if updates are rare. Long polling would be an alternative, holding the request open until there is something new, but this can still be inefficient and introduce latency, which isn't ideal. Server-side events come into play as a potential solution for one-way communication from server to client, ideal for updating available games in real time. However, for the in-game experience where bidirectional real-time interaction is crucial, server-side events falls short because it only supports server-to-client communication. It brings us to WebSockets, which enable full doublets communication. They are ideal for the live, interactive aspects for gameplay. Given this, even though server-side event would work for game listings, interpreting it means we would be managing three different communication methods: REST, server-side events, and WebSockets. To simplify our structure and architecture and avoid juggling multiple protocols, we will use WebSockets for both the game listings and the gameplay. This decision is rooted in a desire for linear architecture and a more unified approach to real-time communication. So, we start with a REST all for setting up the game, and then use WebSockets for everything else, ensuring a seamless real-time experience without the need to manage different communication strategies. So now we have three endpoints: API game init, where we need to add in the body game setup, and it returns game ID. Another user should use the first WebSocket, where he or she receives games. It will be game setup array. And when another user decides to start playing, we initialize our last endpoint. Our WebSocket allows us to handle different states. For example, open, show loading state. When we have error, show error state. When we receive different message, we can handle all actions during the game. You can see the example. The next topic is optimization. So, what we are going to do here? We can use broadly or gzip for operating text-based assets, HTML, CSS, JavaScript. We can use broadly for modern browsers and gzip for older browsers. Because we are using different images, don't forget to use WebP and apply responsive image techniques using picture tag. The next optimization through shading, where we are going to remove unused odd. Then we can use odd splitting for loading necessary odd on demand. Also, we can apply reticle CSS techniques and use preload for important styles and scripts as well. I can proceed, but I would like to focus on how we will check if someone has a winning combination and try to optimize this algorithm. The best idea is to try only moves. We don't need to iterate by all matrices. Instead, we will try users' moves only. We start with 4 variables: rows, columns, diagonal, and anti-diagonal. As we go through the game's moves, which are just pairs of row and column numbers, we update these variables based on where each player places their mark. Every time someone makes a move, we check our variables. If the total in any row, column, diagonal, or anti-diagonal hits exactly 3, for example, or -3 for the other player, boom, we have got a winner. This way, we are only focusing on the moves made, making it super efficient to see if someone's won, if it's draw, or if the game's still on. Pretty good, right? The next and last topic is accessibility. We need to implement adjustable algorithms and allow preferences to be saved for future visits. The next requirement is to ensure the UI is fully responsive and elements remain accessible across all device sizes. Because we have different images, don't forget to add alt text to understand what exactly this image shows. The next requirement is that motion animation triggered by interaction can be disabled. And also, web pages don't contain anything that flashes more than 3 times in any 1-second period. Before I start talking about abort, we need to be sure that focus is visible and has correct order. In general, what I want to say here in the accessibility topic, we need to be sure that all actions as reader friendly, and explore maybe advanced features like voice input integration for an inclusive gaming experience, enabling users with different abilities to enjoy the game. That's all, to be honest. I hope you find it useful. Don't forget to add your ideas on what we can add to this design in the comment section below the video. Bye.